Good morning, girls. 13 students joined all together. In a minute from now, we are going to start the class. Today's class is on lines. First, I'll cover the different forms of lines. Then I'll discuss with the formulae that we come across while doing the problems in the exercises. Then I will explain to you 4 different models today. And then you are required to do the problems based on these 4 models. These 4 models are very, very important, actually speaking, for short answer questions and also for doing some problems in pairs. Okay, so please pay attention and listen carefully to the class. I'm going to start now the class. It is 11:50. Now, lines. It is second unit, girls, for us, you know. And you have seen the various forms of lines. Here it is a revision class to you girls. We had enough revision in the college. Again, we are doing now revision online. Now, the very first one is symmetric form of a line. This is the equation of the line through the point x1, y1, z1 and DC is LMN. So x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N is the symmetrical form of a line which is passing through the point x1, y1, z1 and whose DCs are L, M, N. Now if you see the unsymmetrical form of a line, it would be like this, intersection of 2 planes. In the previous class, you have seen the planes. So when 2 planes intersect, you get a line. So this is called as unsymmetric form of a line. Now, how to find out equation of the line passing through 2 points? So, if P, Q are the 2 points through which the line is passing, then you can write this formula to find the equation of the line. So, the first one is symmetric form of a line. Second one is unsymmetrical form of a line. The third one is equation of the line through 2 points. Now let us see some of the formulas. Now how to find out the angle between 2 lines? You can see the formula cos theta. It is similar to that of angle between 2 planes. Okay. So if L1, M1, N1 are the DCs of the first line, L2, M2, N2 are the DCs of the second line. And if theta is the angle between these 2 lines, then cos theta is given by this formula, from which you can get the formula. From this we can find out the theta. Now you know when 2 lines are intersecting, there will be 2 angles. One of the angles you can find by using this formula and the other angle you can obtain by writing pi minus that angle, 180 degrees minus the angle. Now when do you say that 2 lines are perpendicular? The 2 lines are perpendicular if the angle between them is 90 degrees. So when theta is 90 degrees, cos 90 becomes 0, so that L1, L2 plus M1, M2 plus N1, N2 becomes 0. So when 2 lines are perpendicular, L1, L2 plus M1, M2 plus N1, N2 becomes 0. Or whenever L1, L2 plus M1, M2 plus N1, N2 is 0, we say that these 2 lines are perpendicular, where L1, M1, N1 are the DCs of the first line, L2, M2, N2 are the DCs of the second line. Now, these 2 lines are parallel if the ratio of their DCs are equal. That is, L1 by L2 is equal to M1 by M2 is equal to N1 by N2. Now, when do you say that a line lies on a plane? Or how will you confirm that a line lies on a plane? There are 2 conditions, girls. See, if you have a line in this form, symmetric form, this line is passing through the point x1, y1, z1. When this line lies on the plane, that point also lies on the plane. So, automatically, the point satisfies the equation of the plane. That is why the first condition is A x1 plus B y1 plus C z1 plus D is equal to 0. Means the point on the line also lies on the plane as the line lies on the plane. The second thing is, you know, when the line lies on the plane, and ABCR being the DRs of the normal to the plane, that normal is also normal to this line. That is why LA plus MB plus NC would be 0. So these two conditions are satisfied means you can say that this line is lying on this plane. Very easy to remember, girls. A line is lying on the plane means point on the line lies on the plane, and the normal to the plane is also normal to the line. So second condition is perpendicular condition. First condition is point lying on the plane. Now, a line is parallel to this plane only when this condition is satisfied. How? This line is lying parallel to this plane means for this plane, the normals DRs are ABC. Any normal to this plane is also normal to this line. Therefore, AL plus BM plus CN is equal to 0. So this line is parallel to this plane only when AL plus BM plus CN is equal to 0. And this line would be perpendicular to this plane if the ratios of the DCs are equal. Now, when do you say that two lines are coplanar? By the way, we all know that lines are coplanar if they are all lying on the same plane. Lines lying on the same plane are called as coplanar lines. But how to determine whether the lines are coplanar? Suppose you have two lines with DCs L1, M1, N1, L2, M2, N2. Suppose that first line is passing through the point X1, Y1, Z1. Second line is passing through the point X2, Y2, Z2. Now, these two lines are coplanar if and only the determinant of this is equal to 0. This is the condition for coplanarity of these two lines. Suppose you have the lines in the unsymmetrical form. See here in this formula, both the lines are in symmetric form, and to check whether they are coplanar, we wrote this condition, and we need to check whether the determinant is 0. Now, if the lines are in unsymmetrical form, how to check whether they are coplanar? For that, this formula will help you. So, if at all determinant of the coefficients of these planes and the constants is equal to 0, then we say that the lines are coplanar. The lines now are in unsymmetric form. So when the lines are in unsymmetric form, you have to make use of this formula to check whether the lines are lying on the same plane. Now, the next formula is about the equation of the plane containing one line and parallel to another line. Okay, so what you have to do is you please put the formula like this to find out the equation of the plane containing this line with DCs L1, M1, N1 and parallel to this line with DCs L2, M2, N2. The first line is passing through the point X1, Y1, Z1. Now, second formula, if you see this formula, this is the equation of the plane containing both the lines. Now here, this is the formula which will help you to find out the equation of the plane which is containing these two lines. Now, skew lines. When do you say the two lines are skew? Two lines are called skew lines if they are non-coplanar and non-intersecting. Two non-intersecting, non-coplanar lines are called as skew lines. See, these are the formulas, girls, which we will be using very often in doing the exercise problems under lines. Okay, you must know the symmetric form of a line, unsymmetrical form of a line, and how to find equation of the line passing through 2 points. Then how to find the angle between two lines and how to check whether the lines are perpendicular and parallel. And then condition for a line to be on a plane. In fact, there are two conditions for a line to be on a plane. Then these are the conditions for a line to be parallel to a line, for a line to be perpendicular to a plane. Now, this is the copolarity of lines when the lines are in symmetric form, and this formula will be useful to find out, to check whether the given lines are coplanar and when the lines are in unsymmetrical form. Okay, and these two formulas will help us to find out the equation of the plane containing one line parallel to other line, or equation of the plane containing both the lines. Now see, if you are thorough with these formulas while reading the problems, when you come across with the same technical words or the same terminology, you can just think of using the corresponding formula. Please be thorough with all these formulas, girls. Let us now move on to the problems. Today I'm going to explain to you again as a revision how to transform a line symmetrical to unsymmetrical and unsymmetrical to symmetrical. How to transform a line which is in symmetrical form to unsymmetrical form. Girls, this is very simple actually. You have seen already this in the class. Symmetric form you have seen, no, this is the equation of the line passing through the point x1, y1, z1 and having DCs L, M, N. Now, this has to be changed to the unsymmetrical form. Unsymmetrical form means intersection of two planes. Now, what you have to do is, girls, these first two, you equate the first two fractions and then equate first and third one. Okay, step one is write x minus x1 by L is equal to the second one y minus y1 by M. And the second one is you equate again the first with the third one. Okay, and now from these two, this equation and this equation, you will have to get two planes, girls. Okay, now how will you get two planes? Just cross multiply. Then after cross multiplying, you will get this equation, and from this you will get this equation, and then bring every term to one side. So you will get a plane of this form, mx minus ly plus some constant is equal to 0 from the first identity, and then from the second identity you will get some nx minus lz plus some constant is equal to 0. These are the two planes, and intersection of these two planes will give you the line. So that's what I wrote here in the last step is intersection of the two planes. Okay, now the given line is in symmetric form. We transform that into unsymmetric form. Here I gave you one problem, girls. Please work this problem and see that you will get the unsymmetrical form of this form. Now what you have to do is x minus 1 by 9 you equate to y minus 2 by 1, from which you get one plane in x and y, and again you equate x minus 1 by 9 to z plus 3 by minus 3, from which you get one more plane in x and z. Okay, and these two planes, when they intersect, you get the required line. So you put the intersection of those two planes like explained in step 5 to get the unsymmetric form of this line. Please do it without fail. Now you have seen how to transform a symmetrical form of a line into unsymmetrical form of a line, which is very simple, girls. Let us now move on to the other way. That is how to transform unsymmetrical form of a line into symmetrical form of a line. Let us take the unsymmetrical form of a line like this, girls, which is the intersection of these two planes. You know, this is the equation of a plane. Okay, standard general equation of a plane. So when these two planes are intersecting, you are getting the line L. Now you are going to transform this line into symmetrical form. Now what are the planes? You write planes here are 1 and 2. Now if you see here A1, B1, C1 are the DRs of normal to this plane 1, whereas A2, B2, C2 are the DRs of normal to the plane 2. Now you are writing the equation of the line, no? So what is this line? This line is intersection of these two planes. Means this line is lying on the plane 1 and lying on plane 2. So any normal to plane 1 is also a normal to L. Any normal to plane 2 is also a normal to the line L. Because line L is lying on both the planes, normal to the plane is also normal to the line L. So we are now going to find out the line in the symmetric form. Means you need to have a point on the line and also its DCs. Let us first find out the DCs of the line L. So let L, M, N be the DCs of the line L. Because L is lying on plane pi 1, means this plane, the normal to the plane 1 is also normal to the line L. So you will have A1L plus B1M plus C1N is equal to 0. The condition for perpendicularity. The same way, line L also is lying on the plane 2. Any normal to this plane is also normal to the line L. So LA2 plus MB2 plus NC2 is equal to 0. Now you have two equations because of the perpendicularity. So now you solve these two equations in step 3 to get the value of L, M, N. This is how you can find out the DCs of the line. Now what else we need to find the equation of the line apart from DCs? We need a point on the line. So let us say that this line intersects XY plane. You can take that it intersects YZ plane or XZ plane also. Now here I'm taking that the line L is intersecting XY plane. Once it intersects XY plane, its z coordinate, point of intersection, if you see, the z coordinate becomes 0. So z is equal to 0 if you see the point of intersection of this line. So what you have to do is now you put z is equal to 0 in the first two planes, 1 and 2. When you put z is equal to 0, you get the equations 5 and 6. Now these two equations are in two unknowns x and y. You solve them to get the values x and y. So after solving these two equations, you get x and y values. So now what is the point of intersection? P, x comma y, and already we took z is equal to 0. So you are arriving at a point on the line now, x, y, 0. Okay. So now you have a point on the line and you know the DCs of the line. So what you have to do is you simply write the equation of the line in the symmetric form, which is x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. So this is a very important problem, girls. You need to transform the unsymmetrical form to symmetrical form while doing some problems. And also you may expect this problem for short answers. So you please follow step-by-step procedure to transform the unsymmetrical form of the line to the symmetrical form. I think it is clear to you girls. Take the given planes. I'm upgrading now the time. Remaining time it is showing 9:15. Why it is showing like this? It is showing that actually the time is up. That's why we have to stop, I think. Now, just know what happened. It is showing that the 10 minutes only remaining. Let us continue and we'll see how long we can continue. Now, I think you understood how to transform unsymmetrical to symmetric also. Okay. I think we better stop here, because in between, if it says the time is up, I think we can, I will call you once again for one more meeting immediately, so that we can resume with the next two problems. Okay, let me stop it here, and I'll again call you now only for the next meeting to continue with the two more problems. Thank you, girls. Anyway, I'll share this with you again today.